I know this would stop working. That's why I told you in the video itself. So what I'm talking about is this a minus x. A minus x is always the same because it's just a difference between the days, no matter how many months you have. Like even in September or October, you just have 31 days or 30 days, which relates to the number of days in one month. But in one day, you have just one day, not like 2 days. We have 2 days on Tuesday, not like that. We just have one day, so it doesn't change. Whatever month you are on, one day is one day. It doesn't increase. I guess you're getting what I'm saying. So if r equals to 1, let's say someone, not me, but someone, a baby, is born. Let's keep two of the variables we give constant. I mean, with the, like, just change only the month and keep the year the same. So 26th, but the month is one month before it. So I'm keeping the year the same as the a. A is the variable I define once again, and 26 is the date I define, but 5 is not the month I define. I define 6, so there's one, something different. See, you get Thursday. I guess that's right because Sunday you have, well, let's say 28 days you have Sunday because it's if you divide 28 by 7 you get 4, so there's no reminder. So if you go back 28 days it would be still Sunday, but we go back 31 days because look, here it says, so what the computer does here defines these variables. So finds the difference between the months. So 6 minus 5 is 1 and checks if these are correct, and if it's correct then it just prints invalid data, but these are not correct currently. So if n equals to 1, right, it's 1, and the difference between the dates, as I said, I wantedly put them to equal to that so that this would be 0, and same with this, but this is not 0, this is 1. So 31 times 1, we have 31 days. So if we say from the 26th June 2016 you are 31 days old. So 31 days is equivalent to Thursday, and I'm going to show you how the other process works, just to show you that it's 31 days. That's how it works at least. So if the difference is 2 or minus 2 or whatever, let's say 1 above it now, 8. So you're born on Friday, there we go. So as I said, as you can see, is 26/6/2016. Let's say if that's the date today, or let's say this is the date, 7/30/2016, but 26/8/2016 is still more than today's date. As you can see, it's July 30th, but here we have August 26th. So that's why even if it's more than this, it can still find out, which is pretty cool about this, right? Isn't it cool? See, no, it checks it -2, right? It's -2. So as I said, I kept this constant and this thing constant, right? So it just goes to here and it sees it's -2, not 2, but -2. 61 over 2 times -2, which is -61. As I said, it still counts if it's negative. Okay, so that being said, I guess this process works for all, and I guess you understood what I'm saying. Just verifies for all these ends. So I have all the months printed, so you don't need to worry about that. Whatever month you give from 1 to 12, it just prints the answer. So that being said, so that's for if n equals to 1, or L if n equals to 2 or -2. And it just goes on, checks for all the variables if it's right or wrong. So what if it's 0? So let's say this. So let's say 6, the same date. You're born on that day exactly. See, you are born on Sunday because it's 0. 0 is still Sunday. And I'm going to show you the next part where you have this condition. So our work doesn't just complete after finding the value of which is the number of days you are old from the particular date. You see, this is the date from which we are consider, let's say this is the point of reference. Yeah, that's good. Point of reference. This is the point of reference. So I'm using that as a reference to how many day how how old you are. So that being said, just I have all the conditions for all the different possibilities because it need to be integer first of all. Well, what did I do? Okay, wait a minute, I did something dirty. Okay, guess that's okay now. Okay, now come on, yes, that's good. Okay, so you see, so we just found out how many days old you are. Let's just print R2 showing how many days you are old. Okay, let's write here how many days, just print how many days you're old. And I guess we don't, never mind. Print or just the number of days here, just to know. 0 days, you see? Now it's more clear. You're 0 days old, and my reference point is Sunday, point of reference. As I said, this is the point of reference, and that is a Sunday. So if you type in the same date, you just get Sunday. You're born on Sunday, dude, which is right. So after defining R, which is the number of days, as I said, which I'm just printing R. I just did it now. So here comes the most important part of the whole code, I guess. Defining a variable m, c minus g. So c minus g is the difference between the years, and you know this is a leap year, and you can check for it in the internet if you're not sure about that. Okay, so difference between the years, and then checking if it's a leap year. So I'm doing the rounding part, as you can see, rounding, dividing it by 4 and rounding it to the well, it's the greatest integer function, and I don't need to talk all about the rounding stuff. So the next thing we are doing, defining one more variable called g as r. You know r is the number of days, right? Reminder 7. So it's like you have these many days, you divide it by 7, and you find the remainder. And this is pretty important because you have 7 days in a week. So I'm corresponding each day to a number. So you may have a reminder of 0, 1, 2, 3, 4, 5, 6. And that's it. You can't have 7 because 7, if you divide 7 by 7, it's just 1. So you can't say 7 is the remainder. And you know the rule is it must be less than the divisor, which is 7. The remainder must be always less than the divisor. That being said, if you look here, you may think this would be the answer. Wrong, you're wrong. What about the leap years? You just left the leap years? That's why, that's the trick part here. Now what you're doing, you're defining one more variable f. There are a lot of defining variables, so you must be patient here. So g, as I said, it's the, for example, let's say there's no this leap year concept, then that would be g would be the answer. But you have the leap years? Okay, that sucks. So because you have to do this again. So you need to add the leap year days. So each leap year you get one more day added because February you get 29, right? I guess that's clear. And you just add how many leap years. So my birthday, let's just take my birthday as a reference. 17/9/2002. Okay, print. Oh, I'm this many days old from that day, that particular day. Well, it didn't add the leap years. Yeah, because I didn't, well, it didn't have the leap days, which are February 29. And it's from this point, not just that point. So, leave it. We are not working for the number of days though. So, next, you see, and I'm again doing the reminder for it over 7 because we have 1 week which have 7 days. So, we always need to do it to 7, not more than anything. Next, we are doing the, well, I just want to don't want to leave anything, so I just making it an integer. So the if by mistake something wrong would happen or